planning phase. The project planning phase is a critical phase in the project lifecycle, as it sets the stage for successful project execution. A comprehensive project plan is essential to achieving project goals, which include meeting technical performance expectations, product and service quality requirements, budgets and timelines, and any other expected outcomes. Inputs that have been validated, along with in-depth analysis, are used during the planning phase to plan for contingencies for expected and unexpected situations, to ensure that the project can move through challenges and roadblocks to stay on track towards the desired results. Additionally, the project plan must take into consideration any internal organizational factors, external market factors, risks, and resource needs that could impact project execution and productivity. To create a thorough project plan, one of the first inputs needed is a detailed scope of work that describes the goals, requirements, and deliverables for the project according to the customer and network needs. A comprehensive scope of work is critical for achieving project objectives and avoiding problematic loopholes. However, the scope should not be overly rigid to prevent limiting flexibility during project execution. During this phase, the high-level design is validated with a low-level or constructible design to challenge or confirm initial project assumptions and estimates with confirmed data. The project plan must also include a communications plan that outlines how stakeholders will be informed of project progress, status, and key performance indicators, or KPIs, to gauge whether the project is advancing as intended. In addition, a comprehensive project plan must include a due diligence process to ensure compliance with regulatory agencies, as well as for obtaining permits and meeting safety requirements relevant to the jurisdiction and place of the work. Failure to meet compliance requirements could lead to project delays or even legal penalties, which could negatively impact project performance. Fiber optic projects have key specific elements that need to be considered during the planning phase. Conducting surveys for gathering graphical inputs and using spatial referencing tools is critical for determining the cable route, cable plant requirements, and choosing the most practical installation methods. Physical surveys or walkouts, whether conducted by personnel or through vehicle-mounted information capturing systems such as cameras or drones, are critical for validating assumptions and confirming the feasibility of strategy and method selection during fiber project planning. Choosing the most suitable installation method is a vital step, and reliable field information should guide this decision. Additionally, the low-level or constructible design should be used for planning the installation work, as well as provide information for calculating power budgets to ensure that the cable plant will meet transmission requirements and perform as intended. For outside plant projects, deployment options typically involve using underground or aerial installation methods. On the other hand, for inside plant or premises cabling projects, it's essential to determine the most efficient and effective use of pathways and spaces while adhering to relevant codes, standards, and building requirements. In fiber project planning, it is critical to develop technical guidelines based on codes, industry standards, and manufacturers' recommended procedures. This ensures that expected technical results are achieved and that vendor warranties are not voided. The technical guidelines should include information such as power budgets and calculated loss budgets for the cable plant. These details help to ensure that the cable plant will meet the required performance to support the network system, specifically when it comes to the distance range of transceivers. Other examples of guideline elements include hardware and materials specifications and installation procedures, as well as specific equipment for splicing and testing the fiber links. Developing a project safety and compliance plan for protecting workers, passers-by or pedestrians, traffic management, or the public in general for outside plant projects should be a top priority. It's essential to have specific guidelines on safety protocols, training, risks, and accident prevention, safety planning, documentation, and reporting systems to ensure the safety of everyone, prevent injuries, preserve lives, avoid delays and financial losses, as well as comply with relevant regulations and authorities. Before commencing any digging or excavations activities, it is imperative to contact 811 if you are in the U.S. or other applicable agencies in your area to coordinate with any other utility companies and implement measures for accident prevention and contingencies. Having a process and acceptance criteria for the project deliverables is also an essential part of the project plan. The project plan should address the process of work validation and acceptance. It should include a detailed description of the expected performance and final condition of all deliverables. This to ensure that the project deliverables can be validated, accepted, and handed over without any issues once the project is completed. Risk management is another key area to address during the planning phase. The risk management plan should include risk identification, analysis, mitigation, and monitoring strategies, as well as strategies for leveraging available tools and systems for monitoring for risks throughout the execution of the project. Examples of potential risks include unexpected events, problems with materials or equipment, problems with contractors, budget or schedule overruns, workforce dynamics, supply chain issues, and many others. A well-developed risk management plan is critical to ensure project success within scope, budget, and schedule. Lastly, the planning phase must include an assessment of resource needs and requirements. Resource assessment involves identifying all the resources needed to accomplish the project's objectives, including personnel, equipment, and materials. It is essential to develop a resource management plan that outlines the procurement, allocation, and utilization of resources throughout the project lifecycle. Procurement involves sourcing and hiring of materials and service suppliers, and selection must be done meticulously to ensure that vendors have the qualifications, experience, and capabilities to deliver as expected. Material and equipment vendors must comply with relevant manufacturing quality standards, and the products must meet local codes and safety requirements to ensure compliance. Additionally, installation services vendors must comply with business and trade qualifications, and any technicians involved in the project should be certified by reputable organizations, like the FOA. After vendors have been qualified, customers typically issue a request for quote, or RFQ, to obtain confirmed information on labor, equipment, material quantities, and pricing, as well as corresponding commercial and legal terms and conditions. For larger projects, a tender process may be used to invite suppliers to bid, which is a more comprehensive procurement process than hiring suppliers based on a quote. While developing a resources management plan, the project manager or team should also consider any external factors that could impact resource availability, such as uncertain market conditions, and include contingency plans to address any unexpected changes and keep the project on track. At the end of this phase, the project manager or team must have a comprehensive project management plan with a well-developed scope of work, communications, risk management, and resource management plans, as well as procurement and vendor selection plans to facilitate project completion within scope, budget, and schedule. The planning phase is critical to the success of a project, and a well-designed project plan is critical for achieving project goals.